Alrighty, so we're going to move on to 8.2, which is changing the period of sine. So what we're going to do first is let's take a look. On the notes from 8.1, I went over the graphs of sine and cosine x, where sine is starting, remember our unit circle, we're talking about the y values. So when, oops, sorry, I wrote the wrong ordered pair. So the y value at 0 radians is 0. So sine starts right here at 0, 0 if we're talking about going around the positive quadrants, okay? If I'm spinning around, this point is moving around to the left, okay? So what's going to happen is as this point moves, here it's going to hit its highest point, which is what happens at pi over 2. Then it's going to keep on moving, and it's going to come back to 0, which is what happens at pi. And then it's going to, this point is going to keep on moving, and it's going to hit its lowest point, a minimum, at 3 pi over 2. And then it's going to keep on moving and go and finish up where it started at 2 pi. This is one full rotation around the circle. But what happens is this point then will continue around. So then it's going to go back up, and then it's going to continue around, and it's going to come back to 0, and it's going to continue around, and it's going to come down to -1, and then it's going to continue back to 0. This is the second full rotation. So when we talk about period, the period is what happens when you rotate around one full time. And we're talking about how many units or how many degrees, or in our case radians, does it take to rotate one full time. Well, one full rotation starting at 0 and coming all the way back around is 2 pi radians. Okay, so this is the parent function. And then I'm going to do it again, 2 pi plus another 2 pi ends up being 4 pi. And if I were to add another 2 pi, it would come back around at 6 pi. So we continue that pattern. All right, so what's going to happen now is I'm going to look at one of these transformed functions, and you should recognize some of these letters like from other functions that we've looked at before. For instance, h and k. Remember when we had like a quadratic where I had y is equal to a times x minus h squared plus k, where h and k were the vertex of the parabola. Well, in this case, it shifts it left or right and up and down. It's the same idea. So shift is going to be talking about my left and right. And then the vertical shift is up and down. Now, it's a little bit trickier with the sine and the cosine functions. Left and right, because this is periodic, the pattern is going to keep on continuing. So we're looking for key or critical values that we're shifting. So what we're going to end up doing is we're going to shift this starting value, this 0, 0. We're going to either shift that left or we're going to shift it right when we talk about phase shifts. We're going to take that 0, 0 and we're going to shift that up or we're going to shift that down when we talk about vertical shifts. Today, though, what we're going to talk about is the period, and that is the coefficient of the x value. So today, this is our focus right here, is what happens when I change this b value. First of all, the period is defined by 2 pi divided by whatever the b value is. This is a really important formula, so this is a memorize. We need to make sure that we memorize this. 2 pi divided by b is equal to the period. So if I look at my original parent function, the coefficient of y equals sine x the coefficient is 1. So if I take the period is equal to 2 pi over b, and I take 2 pi divided by 1, the period is 2 pi. And that is how long it takes to complete one full rotation, and that was 2 pi units. Okay, so how is that going to affect our graph? Well, it's going to either shrink it or it's going to stretch it. Okay, so if we take a look at the graph of y equals 3 sine 3x, okay, this right here, this is my b value. So what I'm going to do, first thing I need to do is say period equals 2 pi over b. So I'm going to take 2 pi divided by 3. This is my new period, which means that I am going to complete one full rotation in 2/3 pi units. In 2 pi divided by 3 units. Okay, so my x value is still going to start at 0, but this time 2 pi over 3 is going to be the end of my rotation. So on my my graph, sorry, my x values, those are going to be going from 0. So I'm going to mark it 0. And then the furthest it's going to go is 2/3 pi. So if I normally have 2 pi over here, and then I know that 1 pi is right here, 2/3 pi is going to be, here's about pi over 3, and here's about 2 pi over 3. I'm going to, instead of it going from here to here, instead of it looking like that, what's going to happen is I have to basically take that and scrunch it. So I'm going to be able to finish one full rotation in that amount of time. So how do we get there? How do we make that graph actually work? Okay, so the first thing is I need to know what is halfway between 0 and 2 pi over 3. Okay, so we need to figure out what these other values are. So this number, this value is halfway. So 0 plus 2 pi over 3. And I want to take that divided by 2. So we're going to have a little bit of fraction fun here. So I get 2/3 pi, and I'm dividing that by 2, which is the same as multiplying by 1/2. And so what happens is I get 2 pi over 6, which is just pi over 3, which I already had on the graph, but I'm going to put that here. So that's pi over 3. Now I need to find the midway between 0 and pi over 3. Everything is symmetric, okay? So now I'm going to take these ones, is 0 plus pi over 3. And again, I'm going to divide that by 2. I'm taking the midpoint. So that's pi over 3 divided by 2, which is equal to pi over 3 times 1/2, which is, pi over 1/2, there we go, which is equal to pi over 6. So that means over here, this is pi over 6. And then I need this value. I shouldn't make a point there. So this is pi over 6. So you can look at it as, all right, so this is 0. This is 1 pi over 6. This was 2 pi over 6. So this is going to be 3 pi over 6, or half pi. And then 4 pi over 6, which reduces to 2/3. But we can see this one here too. This is 0 plus 2/3 pi divided by 2. Oh, I'm sorry, it's not 0. I'm looking for halfway between pi over 3 and 2 pi over 3. So this is pi over 3. So that is equal to 3 pi over 3 times 1/2. Well, 3 pi over 3 cancels, and so I get pi over 2. So there you go. See how we have those values? Now, from here, we have to remember what happens when when we start at 0. So the sine function, it goes 0, then max, then 0, then min, then 0. Okay, so we're going to go 0, then max, then 0, then min, then 0. My amplitude does not change. My maximums and minimums do not change. Okay, so I'm still keeping that same pattern. I'm just smushing it. All right, so that means for one period, I'm going to end here. So I'm going to start at 0. I'm going to end at 0. I'm going to have a middle value of 0. And my maximum was 1. And my minimum was -1. So I'm going to go up. And then I'm going to go down. Those are my 5 critical points. And I'm going to connect them with a smooth curve. Okay, and so what's going to happen, this is going to keep increasing, and this way it's going to keep decreasing. And we could do another cycle. It would just be, oh, I'm sorry, I totally did that wrong. I smushed it together too much. It shouldn't end at pi. It should have ended at 2/3 pi. And I needed 1/2 pi on here, pi over 2. My mistake. So then I should be at 0. It's still the same pattern. I just didn't smush it close enough together. All right, so we go up and down and up, and then that would be continuing to go down. So then I could do another cycle, and I could figure out, well, if I have 2/3 pi, so that's 2 pi plus 2 pi over 3. So 2 pi over 3 plus another 2 pi over 3 is equal to 4 pi over 3. So we would have, like here, we would have another cycle. Okay? So, but we're only doing it over one period. Okay? So let's take a look at the domain and the range. So the domain is all real numbers still, because this graph is going to keep going left and it's going to keep going right. The range still has a y value as a maximum of 1 and a minimum of -1. My period is 2 pi over 3, so this changes. My amplitude is still 1 because it only is going to go up to a maximum of 1 and a minimum of -1. My x-intercepts, so I have 3 of them for this sine function. My x-intercepts are 0, 0, pi over 3, 0, and 2 pi over 3, 0. My y-intercepts, there's only one of them. It's intersecting the y-axis at 0, 0. Okay, so I know that was kind of a long process, but you know me, I talk a lot during these things. So let's look at number 2. I'm only changing my period for these problems, okay? So now I'm looking at sine of 2/3. So my b value is equal to 2/3. So start with, what is the period? The period is equal to 2 pi divided by b. So I have a number divided by, a fraction here, which is equal to 2 pi times the reciprocal. So what I have is now 2 times 3 is 6 pi over 2. So my new period is 3 pi units. Okay, so this is how long it takes for one cycle. So starting here, this is my sine. I start at 0, I hit a max, I come back to 0, I hit a min, and I come back to 0. So that means that I'm going to have 0, a max, because my amplitude isn't changed, my min, or I'm sorry, back to 0, my min, and then a 0. So my question is, what are these x values? Well, the first one is always 0 because I'm not shifting a phase, I'm only changing the period. My max, or my end of my period is 3 pi units. What's halfway between 0 and 3? 0 plus 3 pi divided by 2 is 3 pi over 2. Well, that's easy enough. Okay, you can also call it 1.5 pi, but typically we don't do decimals, we're keeping with fractions. So now what's halfway between 0 and 3 pi over 2? So 0 plus 3 pi over 2 divided by 2, or 3 pi over 2 times 1/2. And so I get 3 pi over 4. And then what's halfway between 3 pi over 2 and 3 pi? So this one's a little trickier. 3 pi over 2 plus 3 pi, and I'm still taking that divided by 2. Well, I need to make this have a common denominator, so I'm going to add a 2. I'm going to change colors here. So I'm going to add a 2, which means I'm multiplying this by 2. So I actually got, using all this space over to the side, 3 pi plus 6 pi over 2 times 1/2. That's this part right here, this denominator. So we get 9 pi over 2 times 1/2. So we get 9 pi over 4. Okay, all right. So now let's go ahead and put those values on. So this is starting at 0, 2 pi, and honestly, it really doesn't matter. You can put, so let's put actually 3 pi. Okay, then halfway between 0 and 3 pi is 3 pi over 2. Halfway between that is 3 pi over 4. Halfway is 9 pi over 4. Okay, we start at 0, 0. The sine starts at a 0. We come to a maximum of 1, come back to 0. We go to a minimum of -1, and we come back to 0. Connect with a curve and add in some arrows. Okay, the domain, still all reals. The range, not going any higher or lower than -1 and +1. The period was 3 pi. Amplitude, highest was 1. This time my intercepts, x is equal to 0, 3 pi over 2, and 3 pi. So you can write them that way. My y-intercept did not change. The y-intercept is 0. Okay, so that was a lot faster going through it. These ones are very similar. Just remember, number 4 is a little tricky because we're not talking about amplitude right now. Just remember that when you're dividing a fraction, it's a keep, change, flip for the fraction. Keep, change, flip for fractions. So if I have 2 pi over b, period is equal to 2 pi divided by the b value. Well, that's 2 pi changed to multiplication. B is 1/4. So that's a flip. Make it 4. So that equals 8 pi. So that means from 0 to 8 pi. This is a little easier. What's halfway between 0 and 8 pi is 4 pi. Halfway between is 2 pi. Halfway between is 6 pi. Because it's sine, 0 max, 0 min, 0. So I'm lengthening this out. This is actually a really quick one to do. And so up, down, down, up. So this was 1, and this was -1. So, whoops, I missed. Here we go. Okay. One other thing that I wanted to show you real quick, and I know that this is a lengthier video, but I promise I'll keep the assignment short. If you look at this on Desmos, so the parent function is y equals sine x. Okay, and I'm going to go over here and I'm going to change my window really quickly to make this go from 0 to 2. And I'm going to need pi. There we go. And then I'm going to change by, pi divided by 2. All right, I'm just going to change that real quick. So that way we can see this window. All right, so take a look. Here's one cycle of sine. Nope, it isn't. Let's move that over. Sorry. I know I'm making you dizzy. All right, so we have 0, 0. Then we have critical value, and we have the other critical value. So there's one full rotation. If you take a look, what happens when you change your b value? So sine, what was the first one we did? 3x. So kind of it looks a little crazy, but if you look at the blue one is more smushed together than the red one. And then if I looked at, what was that last one? Y equals sine of 1/4. Oops. 1/4. No, I don't want to do that. 1/4 x. There we go. Look at this one. So I'm gonna push this together for a second. I'm gonna turn this graph off because the blue one is making me dizzy. So if we take a look at the green one versus the red one, take a look at this. So I was able to get one, man, it's glitchy. So if I was able to get one rotation in this first 2 pi units, take a look at the green one. The green one, I wasn't able to get one full rotation until 8 pi radians later. So notice how when the sine value has a coefficient of 1, 2 pi, when it was 3x, it smushed it together, right? Made it happen a lot faster. When I had 1/4, it spread it out. So taking a look at these values of 3 versus 1/4, when the number is bigger, it smushes it together. When the number is smaller, it stretches it out. Okay, so that's kind of the big idea of this unit, or this section, I should say, and hopefully that will help you with your assignment. All right, happy graphing, guys.